Rob Chandhok heads up the software strategy at Qualcomm, as well as serves as the president of the Qualcomm Innovation Center, which is the organization that provides open source enablement for Qualcomm technology and works with the open source community and is actually growing into a very large organization that's really making a big impact on a lot of open source projects all over the spectrum. Rob's going to come and talk about what a world will look like when everything is connected and how open source is going to fit into that. So without further ado, welcome Rob Chandhok.
Morning. So the last tech conference I was at was actually DEF CON in Vegas, and the big difference here is that I actually didn't have to bring burner phones to the conference. So first of all, thanks for coming and thanks for listening. I'm sorry I didn't get to the party last night. Jim and I did have a pretty nice dinner, fairly entertaining. I'm going to talk a little bit about a topic that may not be what you think of as mainstream relative to the open source community, but it really comes out of, and I hope you'll get to it by the end of the talk. You'll see why I'm talking about it, because it really comes out of an initiative that we have going on that I think surprising to a lot of people we're doing completely in open source, and I'll get to talk about that. But I want to give you a little bit more, if you'll indulge me, of a position and a point of view about where things might go, especially as it relates not just to cell phones, which is what we sort of usually are positioned as working on, but broadly with connectivity overall. Some of you may be aware that Qualcomm, over the last couple of years, it was about a little over a year ago, we acquired and merged with Atheros, which does a lot of Wi-Fi connectivity in the home and the backhaul network. So we have an interesting position to think about how things can connect not only in the mobile environment but across the home. There we go. So the opportunity that we're talking about is not small. I mean, we're talking about enormous amounts of devices. Just even if you take away the mobile side of the equation, it's over 650 million devices, PCs, tablets, estimated to be sold through 2016. And a lot of that landscape is changing. You see with Windows RT coming out that there's a blending of different architectures that are happening. You see the work that is being done on the Linux side and stuff that we've been working on a lot, where you've got this sort of interesting layering of software, and a lot of it, I would say a majority of it open source, that's thinking about the world of heterogeneous computing. And that in and of itself has enabled us to think about different problems. I could spend a whole lot of time talking about that too, but I'm going to try to stay on topic. On the other side, it's sort of interesting to look at where some of the growth in the market is happening. The US markets, the European markets, they're starting to become, I wouldn't say saturated, but there certainly is a large penetration of smartphones there, and it's still continuing to grow. But if you look in the developing markets, that's where you're really going to see an enormous amount of growth in what we think of as really computers in the palm of your hand. Android with Linux in it is becoming that computing platform that a large portion of the world is going to experience the internet on for the first time and probably for a long time. So it's a really huge opportunity out there. The kinds of tools that we put out, the kind of ecosystems that we build, the kind of infrastructure and platforms that we think about can enable ecosystems really broadly and really quite differently than what we did in the past couple decades. My first experience with Linux was actually when I left Carnegie Mellon in the 90s. I had been there as a researcher and started my own company. We realized that where we lived, we didn't have any internet access. We started an ISP just for us to have internet access and then also to provide it to the neighbors around us. And because I didn't want to spend a lot of time thinking about what I would have to do to protect those boxes, I ended up running Linux on DEC alphas, the multis, if you can remember that. There was a fire sale in around 94. You could get these things for a couple $100, and I could run a whole ISP, full news feeds, everything on top of Linux machines on 4 DEC multis for a couple thousand people that were being serviced. Fast forward to now, Linux is everywhere. Linux is the basis for so much growth in the mobile industry, and now I want to talk a little bit about what we take with that approach of building that ecosystem and platform and apply it more broadly across other kinds of connectivity and other ways of thinking about connectivity. So let's step back even further. If you thought so we sort of started with this $650 million number thinking about the PC and then went to the mobile phones plus sort of the compute platforms. Then step back to what a lot of people call machine-to-machine or the Internet of Everything. Things that are going to be connected somehow but may not be big computing platforms. Things like your light switch, a thermostat, right? A smart TV. Other things are going to be connected, electric meters. There's sort of a wide range of compute capabilities to these things, but as we get more and more capable, the ability to provide computing power at these nodes in the network is going to get easier and easier, right? The kind of computing power that we now put out in our 28 nanometer platforms it's really kind of insane. It dwarfs what I was talking about with these DEC alphas that I was running full ISPs on, right? And I can carry that around in the palm of my hand. But we're working on getting those price points down. We're working on making the connectivity work better because we're going to see billions and billions of connections worldwide of these things. So what I want to think about today a little bit is, what are we going to do to have all these things talk to each other? How are we going to build a platform where that's going to be interesting? What are the problems that we have to solve there? Because it's this community, in my mind, that is actually going to help build that platform, build the next level of the Internet, is the way I think about it. Just step back again. If you think about it, the beginnings of the Internet were really about sort of another abstraction, another cycle through the client-server architecture. It was really a way of, at first, abstracting servers from clients and making things basically remote a display somewhere, not that much different than X Windows when it first started. Although if you look back at what Tim Berners-Lee and the researchers were doing with hypertext, there was a new side to it. There was a vision that they had about sort of hypertext and literacy and how sort of academia was going to evolve that in large part sort of happened and in large part sort of didn't. I mean, even after hypertext and HTML came out, I was still writing papers and publishing them as PDFs, not as hypertext documents. But the other thing that came along that started to become really interesting, and this really was because of standardization of protocols. When the first browser came out, if you remember Mosaic wasn't just an HTTP browser. Mosaic was Gopher and FTP and HTTP and NTP and all these different protocols, because at that point it was easier to write a client that spoke all these languages than it was to actually change the servers. But then over time people realized the power in the platform and the power of the ecosystem was in having all the services be exposed through the same protocol, through HTTP, and then later on JSON and RESTful APIs and so forth, and then have clients be able to mash up and mix up and reference on what looks like what used to be a single UI, or what we think of sort of as a page, but be able to mash these things up from all kinds of sources. So that was sort of a very different leap from the sort of singular relationship between a client and a server that used to be sort of the original paradigm. Now, I want to think about towards the future and where we are right now. Think about the devices that we're carrying now. Think about the kinds of both compute and connectivity, sensing, and other aspects that are in your pocket right now. You've got the wide area connectivity, 2G, 3G, 4G, any number of Gs that you want to talk about. It's a real big focus. It's changed the world to be able to walk down the street, to be able to drive down the road at 65 miles an hour, and actually still be getting a megabit per second. We've got Bluetooth for local connectivity. We've got future-looking peer-to-peer technologies, physical layers that we're working on at Qualcomm, like LT Direct. You've got Wi-Fi in all its iterations. We've got 11AC coming out, which is going to be, I think, really exciting. We've got AH, which talks about how to do things peer-to-peer. You've got Wi-Fi Direct, which was, in my mind, a physical layers person's view of what peer-to-peer should look like. You've got all these sensors that actually can do interesting things to interact with you and sense context in the environment around you. And there's, of course, location, which is a blend of actually a lot of these things all together. It's information from satellites. It's information from inertial sensors to do dead reckoning when you can't see the satellite. It's starting to be indoor location based on Wi-Fi and other signals. So you basically take anything that you can use to get indoor location, and it combines it up into a service that's kind of interesting. Well, that stuff's really cool, but we tend to actually focus on each of these things as their own individual protocol stack and their own individual ecosystem, right? You think about Bluetooth accessories, and they speak a different protocol, and if you want to have a new kind of interaction with Bluetooth, you actually have to build a profile and standardize it and somehow get it out there. As a software person, to me, that feels like a hardware person's view of the world, right? So hopefully we'll, and I'll talk about where I think we could go with this. Now, if you multiply all those sensors and you multiply all of that compute power and the devices that we have out of there, you realize that around you there's a lot of proximal data. There's things like the network that I'm connected to in the coffee shop. There's the printers that are near me when I'm at work or at home. There's my friends that might be nearby. There's services that give me information about the concert that I'm about to go to that I might do with a barcode, or at some point, hopefully, I could do with some other kind of technology. And if you start thinking about that and how we might apply it, you sort of get to the point where you start to use a buzzword that people have used over the years that can mean different things. But if you think about it as mesh computing, so if we were all talking to each other, what is the kind of compute environment that we could have? But if you look at this picture, one of the challenges with it is that everything is talking different protocols to each other. This isn't a world where we're actually have a way of mashing up anything, like in that previous example I gave of what we've done with HTTP and the internet, or the interwebs, or whatever you want to call it. If you look and take each one of these colored lines as a different protocol, you see that I have to think about 20 different things to actually do something interesting. I have to talk this protocol to this satellite, and I have to coordinate these things. And it just gets to be something that actually is quite challenging. So one of the projects that we've been thinking about at Quick, and one of the things that I personally am very interested in, is like, what is going to change this landscape? What's going to take the proximal computing environment, the mesh computing environment, the world around you, not the cloud, and I'll talk about what the differences this is between the broader capital I internet, which I'm not criticizing, I'm just saying it's different. What could we do to actually take this to the next level? What is that thing that reduces this sort of Tower of Babel into something that could be interesting? And I don't know how it's going to go, but I have this feeling that it's going to be really interesting. So what I really want to think about is, how do I build a system where in these experiences that I want to build, with my television, with my car, with my gaming system, with my phone, how do I have a platform layer for communication where there is security, where there's trust, where there's services that are useful, like a shared notion of time, all these things, so that I can start to abstract myself from worried about, I'm going to do this really cool thing with Bluetooth so I can do a multiplayer game, but first I have to write a Bluetooth driver, to I want it to be as easy as, hey, you know what, I want to make these two websites talk to each other, so I'm going to take this JSON protocol, I'm going to do this on top of Apache and a bunch of other open source stuff, and boom, I'm just worried about my application layer logic. I'm worried about building the experience, right? And so what we've tried to do with the project, and I will put it up here as a proposal, there we go, is build a platform which we call AllJoin. AllJoin is designed to be a radio layer independent and operating system independent platform for doing peer-to-peer communication. And a lot of it feels like things like Rendezvous, and if you're as old as I am and you remember Apple Talk, there are some things, because Rendezvous is related to the name binding protocols and discovery that were in Apple Talk, it has some feel of that. It's building a local, completely decentralized network and having the system itself maintain the mesh of connectivity across possibly multiple physical layers. So you could have an AllJoin mesh that is partially on Bluetooth and partially on Wi-Fi and partially on Wi-Fi Direct, and the underlying service protocol will take care of it, so that you can have a very simple, very straightforward message passing bus, discovery, authentication, and messaging service platform. In fact, it's built on top of the dbus APIs. It's actually, you can plug AllJoin in, and just if your application uses dbus to talk to other services on the same computer, you plug AllJoin in, and all of a sudden you can talk to things on other devices in the local mesh around you. Now, interestingly for Qualcomm and Quick, AllJoin is completely an open source project. All right? You can go to alljoin.org, and the only thing you have to remember is there's a Y in it, not an I, but that's a long story about trademark that we won't get into. And you can actually go look at the source, hopefully contribute, and tell us what you think about it. Because one of the things we're trying to do is get to the point where, the example I like to give is, in the current state of the world, you would never get to the point where you'd be able to walk into your house and say, Siri, turn on my lights. Because it would have to be an Apple light switch, because that peer-to-peer protocol right now in these ecosystems, and you can look at, and it's not just Apple that does this, is vertically integrated. And there's a reason why they do that, and there's a reason why Google does it the way they do, and there's a reason why Microsoft does it the way they do, and there's a reason why we should think about it differently, because it's hard. It's actually hard to get this stuff right, because it is a Tower of Babel out there. So what we've been trying to do is actually focus on where we think the world is going to be going. I'm not proposing, although you could use AllJoin for this, to blend Zigbee and all the other low-power protocols together, because I happen to think in less than 2 years the world is going to be low-power Wi-Fi in the home, because the trajectory of that technology is going so quickly. Right? I think it's going to be a blend of, in transition, a little bit of Bluetooth, but more and more of Wi-Fi, because we're getting Wi-Fi down to a really interesting power profile. But more importantly, as a community, it would be really good for us to have this platform that does to the Internet of Things what HTTP did to the capital I Internet, which it let us build interoperable systems. So I was at Computex, I don't know when that was, January, well, June, whatever year it is. And you know, at Computex, the big thing, one of the big things for which is the big consumer electronics show in Taipei, one of the big things for the television vendors was to march out their smart TV, and everybody brought out their smart TV, and they said, and here's the Android application for my smart TV that lets you throw a picture from your Android photo gallery onto the TV. Well, I have 3 different brands of TVs at my house, so I have to have 3 different Android applications if I want to do that. And it's just not an experience that I want to do. What I want there to be is a service that my TV advertises called I Can Display Media, right? And in fact, what the one I really want is, I want my television to be able to say, I can show notifications. Think if I had Growl or an equivalent to that on my TV, how many cool things I could build on top of that, right? Anyway, that's just a personal thing, but you could build that on top of AllJoin. So let me step back a little bit and talk about the developing world and give some examples. So we went back and forth on putting this picture in the deck, because it's kind of a gratuitous picture of satellite dishes. But if you think about it, this is the difference between what I was talking about 2 kinds of thinking about the connected home and the Internet of Things. One is a world where every device, like every home in this picture, is basically standing next to each other, pointing at something else, the Internet, the satellite, something else, even though there's something right next to you that you could talk to. But the way I'm going to talk to it is by going up there and coming back down, right? And that's an interesting thing when you're in a world where everything is broadband connected. Well, first of all, I would say that I would challenge it that doesn't scale. At some point, that runs out. When you have billions and billions of devices, you're going to need to use the spectrum that's near you, actually, to do the communication and bridge that, maybe at some point to the big Internet, or maybe for privacy reasons, I don't want that data going over the capital Internet. Maybe when I tell my thermostat to do something, I don't want Google to know about it, right? So it's something what I think is really interesting from a sort of architectural standpoint and from a scale standpoint. And the places that I think might exploit a lot of it first are actually the developing worlds, where there isn't broadband everywhere, where the main connectivity to the Internet is actually over the wide area cellular network. But that network in and of itself is not necessarily reliable or has the capacity to do all the local communication that you might want to do. So one of the things I was just reading about, it was just forwarded to me, that's pretty cool. There's a concept of thing called mesh potato. How many people have heard mesh potato? Which is a really cool Wi-Fi-based mesh telephone network, where you basically drop a node into your house, plug it in, and it finds things near it, and you build slowly a network up. And that's built on top of a bunch of open source technology. You know, it's got Asterisk as its call center and a bunch of other stuff. But it's building, using Wi-Fi, this mesh of connectivity that at some point one node in the network might be connected to the Internet, and therefore you can share that connection. But it's providing a service in a place where otherwise there would be no connectivity and there would be no communication. So I think that's really interesting. And I sort of contrast that to the things that we've been using AllJoin for in more of the developed markets. A lot of our focus and a lot of our interest has been with companies that we've been building that are taking games and making them multiplayer, right? Or building experience where we're going to share music with the people around you. Or, you know, as an example for the my friend from Facebook that's going to be coming up here, what if I were in this room and I wanted to see who in my Facebook social graph was actually near me and that I could communicate with, and I could build a local chat room that wouldn't actually have to depend on anything else. So there's a lot of different kinds of use cases that you get, but fundamentally, I think the thing that's really exciting is thinking about what do we have when we blend proximal communication and computing and the big internet, and thinking about how those two things blend and how they might go together. So in the future, I'm hoping that what we get to is this common platform, and that platform really does have to have a strong sense of security. And if you go and look at the AllJoin stuff, you'll see that we didn't define exactly what security meant. What we did is we defined a security framework and then implemented 4 or 5 different security policies, some certificate-based, some shared secret-based, and so you can build different experiences, or you can build them through some other external authentication mechanisms. And that you can use that then to tie together a bunch of services. You can publish things around you. I could be walking past something, you could say, hey, I have a coupon for you. Whether I want to do that or not, I think it's interesting to have a platform that could enable that. You could share network resources. You could share other kind of resources like scanners and printers and other peripherals through these local kind of connections. And then you can also do things, and I think another edge of it is actually augmenting reality with the things that are around you. So in this mesh network, one of the things that's interesting about if you have a communications platform, then the things you can do where I use my visual, like my camera, to augment information about what I'm seeing, that information can actually come locally, right? So instead of me holding it up and seeing Mark's face over there and getting annotation about it, it would actually happen that his device could actually broadcast what he wants to broadcast about his information, and it could be confined to the local environment. So anyway, hopefully that's a quick tour of what we have at Vision. I encourage those of you that are interested to actually go check out AllJoin and give us feedback and join the crew. There's a bunch of demos out there outside, and some of the engineers are actually here that have done it. And my time's up, so thank you very much.